When you see a fraction, you often see it represented as the two-story method, such as a divided by b, where a is the numerator and b is the denominator, both of which in this case are raised to the first power. And you are likely familiar that you could represent this as a slash b if you choose. But there's another way that these can both be represented, and that would be a times b raised to the negative power that it was in the denominator. This method, this one-line method where it's multiplied by an inverse rather than divided, is an example of how you may see units in upper-level math and science courses. The way that you would turn that into the different way for this one would be c times d to the negative 2. The reason that it's negative, as you should remember, is when there's a negative exponent, it does not mean the value of the unit or the number is negative. It just means that it is inverse or in a denominator position when represented in a traditional way. How would you represent e squared divided by f cubed? In a one-line format, it would be e squared times f to the negative 3. You may not see a dot or a multiplication symbol. You may just see it written as this, and they are equivalent. G to the second divided by the product of h to the fourth times j to the third could also be written as g squared times h to the negative fourth j to the negative third. In the context of real units, you've likely seen grams per milliliter for density. Both of these are equivalent to each other, and they can be rewritten in the form of grams times an inverse milliliter. This is similar to grams per cubic centimeter, rewritten also as a gram times an inverse cubic centimeter. One unit that you will see in chemistry is a unit of concentration called molarity, which can be represented as moles per liter. It could also be written in the one-line format that we have just reviewed, which is moles times an inverse liter. I'll conclude this video with two physics-related examples. Meters per second, represented as this or this in common fractional notation, is a way to represent speed or velocity, which is distance divided by time, or displacement divided by time. These are both or equally represented as meters times inverse seconds. This would be an example of velocity. Acceleration would be the units of meters per second squared, which we know now could be represented as meters times seconds to the negative 2. When you see representations such as these, don't freak out about if they are more difficult than what you're traditionally used to. They are simply another way to represent what you already know.